Press the bell icon on the YouTube app and never miss another update.
Show that the function defined by z of x equal to x minus step x is discontinuous at all integral points. Integral points means that I or z, it is denoted by I or z. Here z of x, the given function z of x equal to x minus box of x. Remember, it is nothing but fractional part of x, that is fractional part of x, fractional part of x. Remember this definition and notation, and it will be 0 less than or equal to fractional part of x is less than 1, that is 0 less than or equal to x minus box of x less than 1. Remember this property. So therefore it is called fractional part of x. It is always lies between 0 to 1. Particularly it may be equal to 0 but strictly less than 1. It should not become 1 like that. So remember all those things. It is useful for this definition, notation, some property useful for competitive track. Okay, here we have to discuss the continuity at integers. That's why let a, that is belongs to I or integer z. So therefore we discuss the left hand limit and right hand limit and f of a or g of a according to second definition, because g of x will contains step x, box of x. That's why we are using or applying the second definition. Okay, left hand limit notation, limit extends to a minus f of x means the given function is z of x. So that is equal to formula limit extends to 0 z of a minus h. So that is equal to g of x equal to x minus box of x. So it is limit h tends to 0 x instead of x we are writing a minus h, a minus h minus box of a minus h, just like that. So that is equal to a minus 0 minus limit h tends to 0 box of a minus h, that is equal to a minus, it is this value is a minus 1. Remember, limit h tends to 0 box of a minus h equal to a minus 1. Next, limit h tends to 0 box of a plus h, that is equal to only a. Remember these two things. Due to this reason, box of x, for box of x limit does not exist, means left hand limit not equal to right hand limit. That's why box of x is always a discontinuous function at integers. This is the main reason. Okay, so that is equal to a cancel, it remains plus 1. Therefore left hand limit equal to 1, that's all, plus 1. Next, let us consider the right hand limit. So its notation, limit extends to a plus given function is z of x. It is nothing but our formula limit extends to 0 z of a plus h. So that is equal to a plus h minus box of a plus h as limit h tends to 0. So that is equal to a plus 0 minus limit h tends to 0 box of a plus h, box of a plus h. So that is equal a minus its value is a, because limit h tends to 0 box of a plus h equal to a. So that equal to 0. So therefore right hand limit equal to 0. Hence left hand limit very clearly is not equal to right hand limit, then there is no need of comparing the value of f of a or g of a. So therefore g of x is not continuous at x belongs to z or integer, any integer. Therefore g of x is continuous, it is continuous at x belongs to I. Hence this problem is very important. Find all the points of discontinuity of the function capital F, where capital F of x equal to sin x divided by x if x less than 0, and for x greater than or equal to 0 it is x plus 1. So clearly it is a discrete function. So first let us take on real line. It is 0. For greater than or equal to 0 means is equal relation is there. That's why we are drawing closed interval. In this case it is x plus 1. Remember, it is polynomial. It is a polynomial. Later x less than 0. Less than 0 means that just less than 0. Like that. Remember, breaking point is 0. So in this area, sin x divided by x, like that. Actually, when x less than 0, capital F of x, that is equal to, it is defined as already sin x divided by x. Sin x divided by x. Further sin x, it is a trigonometric function, and x, it is a algebraic function, means polynomial. Further, both are continuous for all x belongs to capital R. Means at every real number sin x is continuous function, and x, of course, it is identity function or polynomial of degree 1. Both are continuous for all x belongs to capital R. So therefore already we did know one formula, basic formula. If f of x comma g of x are continuous function, then f of x divided by g of x also it is continuous function, whereas g of x not at all equals to 0. So therefore x is in denominator. So therefore means we can write the common domain or common point r minus 0. So therefore sin x divided by x, is also continuous at x belongs to every real number but except 0. Okay, so this is one result. So sin x by x is continuous at x belongs to capital R minus 0. Therefore when x less than 0, capital F of x is continuous at x belongs to capital R minus 0. Right, this is the main result. Remember, next when x greater than 0 or greater than or equal to 0, f of x is defined as x plus 1. It is a It is a polynomial. It is a polynomial. So therefore, every polynomial is continuous at x belongs to capital R. Capital R. It is a superset. It is the subset because in this set 0 is not there. Here 0 is there. Therefore, capital f of x is clearly continuous function at x belongs to capital R common domain minus 0. So therefore, what we so far we proved that in this area capital F of x is continuous, and in this area also capital F of x is continuous. Now it is enough to prove at origin, at the breaking point. You come here. Now at the breaking point, breaking point x equal to 0. At the breaking point x equal to 0, for which left hand limit equal to limit x tends to 0 minus capital, our function is capital F of x, that is equal to formula h tends to 0, capital F of 0 minus h. It is nothing but limit h tends to 0, capital F of 0 minus h. Here actually it is, what does it mean? X less than 0. So in this case x less than 0, you come here, x less than 0, the function is defined as sin x by x. So here capital F of x equal to sin x divided by x. So therefore limit h tends to 0, capital F of minus h means sin of instead of x write minus h divided by minus h. So that is equal to basic formula sin of minus theta equal to minus sin theta by minus h. So minus plus. So that is equal to limit h tends to 0 sin h divided by h. So the basic formula is limit theta tends to 0 sin theta divided by theta equals to 1. This is the basic formula. Due to this it is 1. So therefore left hand limit equals to 1. Next, now we are discussing right hand limiter. So that is equal to limit x tends to 0 plus capital F of x. So that is equal to limit h tends to 0, capital F of 0 plus h. It is nothing but capital F of h, means limit h tends to 0, capital F of h. Actually 0 plus means it is greater than 0. You come here, greater than 0 case x plus 1. So here rough work, capital F of x is taken as x plus 1. So that is equal to limit h tends to 0, capital F of h means h plus 1. So putting h equal to 0, it is 0 plus 1, that is equal to 1. So therefore right hand limit, that is equal to plus 1. So this is right hand limit, and also capital F of 0, you come here at x equal to 0. This case is included at x equal to 0. It is defined as x plus 1. So means what? X plus 1 at x equal to 0. It is the complete meaning. So 0 plus 1, that is equal to 1. Therefore left hand limit equal to right hand limit, that is equal to capital F of 0. Therefore capital F of x is continuous at x equal to 0. Let it be Roman number 3. This is the third statement. You come here. Next, capital F of x is continuous at means when it is greater than or equal to 0. Let it be Roman number 2. Next, in case of x less than 0, means let it be Roman number 1. You come here. Therefore capital F of x is continuous for all x belongs to capital R, because you come here, when x less than 0 it is continuous, in this area it is continuous, in this area it is continuous, at breaking point it is also continuous. Therefore in all areas f of x is continuous. That's what I am telling. Capital F of x is continuous for all x belongs to capital R. So therefore no point of discontinuity of the given function. Hence the question number 23, 28, 29 are of same model. I did 23. Do yourself question number 28 and 29. It is for homework. Later, question number 26, most important question. Here, f of x is defined as actually at x equal to pi by 2. So this is pi by 2. If x not equal to pi by 2 means that total in this area, just at deleted neighborhood. This is called deleted neighborhood at x equal to pi by 2. In this area, it is defined as seen k cos x divided by pi minus 2x, k cos x divided by pi minus 2x. But at x equal to pi by 3, it is defined as, means its functional value is 3. So therefore, what does it mean? That is f of pi by 2 value is equal to 3. Just like that. Of course, it is not a discrete function. We need not to apply the second definition. Means we need not to go for left hand limit and right hand limit. One direct application or definition, I said limit x tends to a, f of x is equal to f of a, then f of x is said to be continuous at x equal to a. It is called first definition. So therefore, because of f of x is not discrete function, we are going to first definition, limit x tends to a, f of x equal to f of a. Now solution. Given that f of x is continuous at x equal to pi by 2. It is given in the question. So that is limit x tends to pi by 2, f of x, that is equal to f of pi by 2. Limit x tends to a, just like that. F of x equal to f of a. So x approaches to pi by 2 means what? X not equals to pi by 2. It is the meaning. So that implies limit x tends to pi by 2 when x not equal to pi by 2 means it is defined as k cos x. F of x is what? K into cos x divided by pi minus 2x, that is equal to f of pi by 2 value 3. So therefore Therefore, it can be written as, that is imply k pure constant with respect to x, limit x tends to pi by 2, it is cos x divided by, okay, just we take 2 common here for our convenient, take 2 common, 2 into, it is pi by 2 minus x, so it is equal to 3, then which implies that k already constant is there, another constant divided by 2 into limit x tends to pi by 2 function cos x divided by pi by 2 minus x, that is equal to 3. Okay, I am introducing one simple separate method for that kind of questions, means at x equal to pi by 2, at x equal to 3 pi by 2, at x equal to pi by 4, just like that. For all that kind of questions, this is the easy method. What is that method? Let pi by 2 minus x is equal to something theta. Means what? As x tends to pi by 2, as x tends to pi by 2, that implies, means put x equal to pi by 2 minus pi by 2 0, theta tends to 0. So mathematically, instead of writing x tends to pi by 2, we can write the same theta tends to 0, means these both are having the same meaning. So therefore, instead of x tends to pi by 2, we can write clearly theta tends to 0. So therefore, that is imply k by 2 into limit, instead of x tends to pi by 2, we can write theta tends to 0 in cos of, what is x? Actually, x values or x limits changed in terms of theta. That's why in the function also, in terms of x, we have to write theta terms. So from this equation, pi by 2 minus x equal to theta. Then what about x here? What about x? What about x? X equal to pi by 2 minus theta, just like that. So therefore, pi by 2 minus theta whole divided by denominator. Pi by 2 minus x is equal to theta, that is equal to RHS 3. So that is implied. So this step is very, very important. Remember, k by 2 into limit theta tends to 0, cos of 90 minus theta is sin theta divided by theta, that is equal to 3. So therefore, to obtain into standard form, we took like that pi by 2 minus x equal to theta, and also total x terms in the given function are changed in terms of thetas. So therefore, that is implying k by 2 into, so this is the standard result. Already I said in 11th standard, limit theta tends to 0 sin theta by theta 1, that is equal to 3. So that implies k by 2 is equal to 3. So clearly k value 6. So therefore, if k equal to 6, then only the given function f of x is continuous at x equal to pi by 2. Hence the problem.